Regression project presentation, and on the left side of my chart is the year, which is also the x-axis, and on the right side is the population, which is the y-axis, and this shows my data of US population over time from 1900 to 2010. And here's my graph. And the orange line represents the predicted values, and the blue dots represent the scatter plot, which is the actual amount. So I used multiple sources to find my information and data. I used immigrationeis.org to find out the data for my population. I also used trackhealthnews.blogspot.com for the price of corn, and I also used youstuckonstupid.com for the U.S. gross domestic product. So my equation is y equals 2,104,000x minus 3,936,000,000. And correlation versus causation means that one thing does not necessarily cause another to happen. For example, the price of living decreased doesn't always mean more population. So for r-squared, slope, and y-intercept, they're very important for residuals and for finding out if the data is a good fit for the equation. So for the correlation coefficient, which is also known as R, I got 0.991, which measures strength and direction of two variables. And it's good to have a correlation coefficient which is positive and over 0.8, because that means that it's a good fit. So based off of my correlation coefficient being 0.991, it's a good fit. Also, my r-squared value is 0.981, which is almost perfect, and it determines how well the regression fits the equation. Since the scatter plot almost forms a straight line, the linear model is used only. The slope for my equation is 2,104,100. The slope shows how steep the straight line is, and higher numbers have steeper slopes. The y-intercept shows where the line passes the y-axis on the graph, and usually a negative population as a total is non-existent. The reason the y-intercept is negative in my graph is because I only looked at 100 years from 1900 to 2010, and not since 0 BC, which is extrapolation. If I looked at the population it's interpolation. If I looked at the population from 0 BC to 2010, the y-intercept would be positive. So for my graphs, I've found other potential explanatory variables such as world population, U.S. gross national product, and price of corn over time. So on the left side of this is the world population, which is a scatter plot, and on the right is the residual. On the left side of this is the average price of corn over time, and on the right side is also the residual. And then my analysis, I didn't have any outliers, but since the 2010 population is a little bit different, it almost is an outlier, but since it's not 1.5 times the IQR, which is 132,852,015. It's not an outlier, and the direction is positive. The form is linear, and the strength is a strong positive correlation, which closely represents a linear equation. Since my data does not have any outliers, the results from the data would not experience any change if outliers were excluded. If there were an outlier, the mean and standard deviation would change. So here's my residual graph over time. And my conclusions is that the population in USA grew steadily between 1900 and 2010. Also by 2040, there will be 356,160,000 people living in the USA, which is based on predictions from my data. And then lastly, the population growth rate per year was essentially constant between 1900 and 2010.
It got all the way through.